We will be going over a brief overview of the lines of defenses, and our house is representative of the human body. Now, as we look at the wall, that is representative of the skin and how it's a barrier that defends the internal human structure. Pathogens can enter the opening, such as a nose or a wound. In this case, they'll be filtered out by nose hairs or trapped in the cilia, and will be ejected through sneeze, cough, and breathing. If a wound is to open, the inflammatory response will engage, meaning there will be redness, swelling, heat, and pain in the area. This is to speed up the healing process, as it sort of hyperdrives the cells as the heat is increased. Pathogens can and will enter the broken skin, but the first defenses are coming in. So this would be neutrophils, which engulf the pathogen, destroying the pathogen and itself in the process. Monocytes migrate from blood to tissues and develop into macrophages, which fight back. And in this case, we see a monocyte moving up towards the wound, and it'll develop into a macrophage right about here. And this allows it to defend more against the pathogens, or better, well prepared. Natural killer cells patrol blood and lymph looking for abnormal cells, and if those cells are infected, they will kill those cells, which we can see here. And a natural killer cell has inspected and then comes back and realizes something is wrong, destroying the cells. On to the third line of defense. Antigens acts like an alarm that gets the immune system amped up. As we can see here, a pathogen invades, which activates the antigen. B cells will mark a particular antigen. As we can see, this B cell is near this antigen and will be activated by a helper T cell, as it is here, and it will begin to multiply itself. Memory B cells remember the old illnesses, making it easier to fight back in the future if that pathogen is ever to come back. Effector B cells are packed with rough endoplasmic reticulum and produces lots of antibodies, as shown here. Antibodies target invaders, but don't kill them, but they do try to neutralize them the best they can. T cells are made in the bone marrow, and this cell will attack and identify cells that have become infected. And here we see a cell inspecting two cells and then discovering one of them is infected. Helper T cells activate B cells and macrophages, and this cell alerts immune cells to any pathogens in the body, as shown here. Killer T cells kill hijacked body cells and will leave uninfected cells alone. Here we can see us, the uninfected cell, walk through and not be harmed, but the hijacked cell will be killed. Suppressor T cells turn off the immune system, as shown here. It gives the signal to this cell and turns it off. The bacterium we have chosen is called whooping cough. Whooping cough is spread through the air by an infected person, and if the person hasn't been infected before, their body can't respond properly. As shown here, the person sneezes and the bacterium is now in the air and has been breathed in by the person. This pathogen enters through the nose, which is considered an opening, and that's where it begins to breed. Once breathed in, the bacterium sticks to the cells in the nose and throat and reproduces fast. As it reproduces, it produces toxins that paralyze cells in the windpipe and lungs that clear airways of mucus and debris, like right here. Another toxin paralyzes some immune cells and prevents attack.
Come here! I dare you!
After some time, the immune system will develop antibodies and begin fighting back, and the lymphatic system then moves its immune cells to fight the infection, even though previously some of them were paralyzed by the bacterium. It will work sooner or later. The underlying theme behind all of this is that our body is under constant threat and is always fighting without us knowing, and when we do notice signs and symptoms, it's because our body is working against the infection.